When we hear landslides, I bet most of us think about significant catastrophic events where large boulders of rock are rolling down the hill, people are being evacuated from their homes, and there's commotion everywhere. And we're right. These big landslides are the ones that generally make the news, the media, and especially Hollywood, has done a really good job of embedding that picture deep in our mindsets. The photo in my presentation tells the story of the Mud Creek landslide in 2017. It's estimated that approximately 4 million cubic feet of rock and soil broke down a mountain slope and buried a significant portion of Highway 1 in California. And so technically, by definition, landslides are really just dislocation and downward movement of rock or sediment. In Canada alone, landslides are estimated to cost about $200 to $400 million annually. Flow volumes of landslides can range from a few cubic meters to more than 10 cubic kilometers, and they can move from as fast as really very imperceptible or to greater than 100 kilometers an hour. And so not all landslides are large. If you look at the map in the presentation, you'll see the map of Canada showing landslide susceptibility. And you would see that virtually the entire Western hemisphere of Canada is actually susceptible to medium to significantly large landslide activity. But on the green side, we are not necessarily out of the woods yet, even though only the large and significant landslides actually make the news. For we as integrity engineers, we are concerned about anything at all that would potentially impact the pipelines, the pipeline facilities that we put in the ground. And there are thousands and thousands of them, within our own, what we call significant spectrum of significance for landslides. Really, it only takes just about 1 to 2 feet of ground movement for a pipe to fail. So that gives you a picture of why it is important to us. And these landslides may be triggered by river to erosion, precipitation, forest fires, anthropogenic activity, and so on. So why does it matter to us? In US and Canada, the pipeline network is over 450,000 kilometers. That's 11 times the circumference of the Earth. And this is really just mainstream, transmission for hazardous liquids. Now, the map in the picture shows you the gas transmission pipelines in North America. And so you can begin to imagine how clustered that network looks. And then just extrapolate that to, for instance, water pipelines, for instance. And you can just begin to imagine, I'm sure there will be no white spaces on that map. And so it becomes important to us as pipeline integrity engineers to really look very closely at every single soil movement that occurs that could potentially affect pipelines. And so our assessment is essentially based on the quantitative risk framework. And this is, we actually basically look at the 3 macro components of risk. We look at the hazard, we look at the vulnerability, and we also consider what the impact is. Failures can generally classified as either girt wall failures, or they could be wrinkle failures, as you can see on the screen. And so landslides are a complex phenomenon. Most important of this complexity is, gathering accurate data. It is very difficult for us to actually be able to gather the data that is accurate enough for us to be able to assess these pipelines. We have so many different types of landslides that could occur, or slope movement that could occur, and it requires thousands and thousands of instrumentation to be able to accurately measure, what actually occurs on these sites. And so we basically try to simplify our approach. The way we start really is hazard identification. We leverage on satellite imagery using LiDAR, and that way we're able to determine what the essential features of slope movement are in a particular site. And that way we're able to escape having to budget thousands and thousands of dollars or even millions to put instrumentation on those sites. And then we move on to vulnerability assessment, which is where we come in. And basically what we do is we perform probabilistic assessment to be able to quantify the uncertainties, myriad of uncertainties that we are faced with when dealing with, when evaluating the risk of failure in different geohazard sites. We further discretize this problem into two major classes: rotational slides and translational slides. And these are basically the classes that we use for assessing pipeline vulnerability at each site. And then we parameterize the features of the site. So we look at landslide mechanics, we look at soil properties, and we look at the pipe properties. And these different parameters, we basically embed them in analytical and empirical models that we use to perform calculations to determine if a pipe will fail due to a landslide or slope movement or not. So once we basically have outlined these parameters, we throw them into, like I said, these analytical equations, and then we carry out probabilistic assessment. Probabilistic assessment really is we trying to calculate the probability of exceedance. So we determine what the strain capacity of the pipe is, and then we determine what the strain demand due to the hazard or landslide is. And then we find out what the probability of the demand exceeding the capacity would be, and so we are able to basically, by doing this, we're able to very quickly calculate how much a pipe is able to withstand a strain demand. And if you look at the graph on the screen, each point on that graph represents tens to thousands of scenarios that we calculate to determine each probability of failure. And so we basically have created a tool that is automated and is highly efficient and is able to, determine help us determine what the risk is for every hazardous, for every pipeline that transports hazardous product through from one place to another. In the past, really, what we would do, and I'll go back to the last slide. In the past, what we would do is we would just determine one failure point, and that failure point basically assumes that the pipe would fail regardless of what landslide occurs. But now we are gradually transitioning, or we're transitioning to the point where we're able to properly estimate, analytically estimate what the capacity of the pipe is and what the demand would be due to a hazard. And so we have developed a tool that makes it a lot more efficient for us to perform these large-scale evaluations, as I pointed out, and perform them efficiently, and also more cost-friendly for our clients.